Okay, section 4. This is piggybacking off of what we did in section 3, where we just did reciprocal functions where we only had to worry about the variable in one spot. We only had to worry about it in the denominator. When you're doing rational functions, this is when you have the variable in the numerator and the denominator. So the definition of a rational function, okay, can be written in the form f of x equals a of x over b of x. So that means that both of those are going to have variables instead of just the denominator. Okay, your vertical asymptote. So we talked about domain with the last one. It's still the same, okay? It's going to be x equals a number. And how you find that number is you're going to set the denominator equal to 0 and solve. Okay, then horizontal asymptote. All right, this is where this one's quite a bit different than when we did the reciprocals. Because if you only had a variable in the denominator, you paid attention to what was on the outside. Well, now when you have variables in the top and the bottom, you have to look at the rules. So you have 3 rules. The first rule, if the degree, so the degree is your highest exponent. If the degree on top is greater than the degree on bottom, then there's no horizontal asymptote. And I'm going to label horizontal asymptote HA, and I always label vertical asymptote as VA. That way I don't have to write it all the way out. Okay, these have something called a slant asymptote. I'm not going to make you do slants, so this one really doesn't apply to you. So the other 2 rules are the ones you're going to have to check. Okay, so second rule, if the degree on top, so the highest exponent, is less than the degree on bottom, then it's y equals 0. Okay, then your third rule is what you do if they're the same. So the degree on top is equal to the degree on bottom. Okay, well if that's the case, then you take your leading coefficients and you divide them. Leading coefficients, numbers in front of your variable with the highest exponent. Okay, so what we're going to do is we're going to be graphing these. We're not going to do any that are like this. We'll focus on the other kinds. Where, I'm not going to make you do ones that have slant asymptote. So we're just going to do ones that have vertical and horizontal. So you'll either have y equals 0 or y equals a different number. Okay, f of x equals x over x plus 2. So if I want to find my vertical asymptote, this is just like how we found the domain before. So if you want to find your vertical asymptote, you set the denominator equal to 0 and you solve. So if I want to solve this, I would subtract 2. So my vertical asymptote is x equals -2. Okay, vertical lines. That means on your graph, you would have a dashed vertical line at -2. Horizontal, you look at the degrees. So I have an x and x. I look at my exponents. I have a 1 and a 1. Those are the same. So you divide leading coefficients. So I look at my numbers in front of x. 1 divided by 1 is 1. So my horizontal is y equals 1. So on my graph at 1, I would have a horizontal asymptote. Okay, graphing. Graphing is the same way that you did it on the last time. You're going to pick two numbers that are on either side of the vertical line. So I'm going to pick -1 and 0 that are on the right side. And then I'm going to pick -3 and -4 that are on the left side. Then I just plug them into my equation. So if I put in -1, this would be -1. Okay, then I have -1 plus 2, which would be 1. So -1 divided by 1 be -1. If I have 0, I would have 0 divided by 2, which is 0. Okay, if I put in -3, I would have -3 divided by -1, which is 1. And if I put in -4, I would have -4 divided by -2, which is 2. Okay, when you're plotting the points, just like before, when you connect them, they curve close to those dashed lines. So -1, -1, 0, 0. So these two, when I connect them, they curve, and they get close to these dashed lines, but they never cross them. Okay, then my other points, -3, 1, and -4, 2. Hang on. -3. It's definitely not 1. Sorry. Because if I plug this in, that's -3 divided by -1, which is 3. So this should really be, I'm sorry about that, this should be -3, 3, and that's -4, 2. Connect them, looks like that. Okay, let's do another one. Okay, I'm going to give you one example of each kind that you're going to see. So this is if you have two things on the bottom that are exactly the same. Okay, well you're still only going to have one vertical asymptote because these are going to give you the same answers. So I set x plus 4 equal to 0. Subtract 4. My vertical asymptote would be x equals -4. Okay, to find my horizontal, look at my degrees. Well, I don't have an x on top, so the group there is 0. I have two x's on bottom, so my degree is 2. 0 is less than 2. So my horizontal is y equals 0. So I'm going to have a vertical line at -4 and a horizontal line at 0. Okay, now graphing it. Same thing, we're going to pick numbers on either side. So I'm going to plug in, on the right hand side would be -3 and -2. and on the left-hand side would be -5 and -6. So -3 plus 4 would be 1. 1 squared is 1, and 1 divided by 1 is 1. -2 plus 4 is 2. 2 squared is 4. 1 divided by 4 would be 1/4. -5 plus 4 is -1. -1 squared is 1. 1 divided by 1 is 1. -6 plus 4 is -2. -2 squared is 4. 1 divided by 4 would be 1/4. So I have -3, -1, -2, 1/4. Those are not negative. So -3, 1, -2, 1/4. So those are here. And then I have -5, 1, -6, 1/4. It'll look like that. Okay, if you have it squared on bottom, where these are the same thing, these will be right next to each other, either both on top or both on bottom. Okay. Okay, we're going to do one more. This is when you have two things that are on bottom, but they're different. Okay, if you have two things that are in the denominator and they're different, that means you're going to have two vertical asymptotes. So I'm going to set them both equal to 0 and solve. So I would get x equals -2 and x equals 5. So for my vertical asymptote, I actually have two of them. Okay. For my horizontal, I have one x on top and I have 2 on bottom, so my degree up here would be 1, my degree down here would be 2. 1's less than 2, so my horizontal is y equals 0. So I'm going to go ahead and draw my lines. Verticals are at -2 and 5. Horizontals at 0. Okay. If you have more than one vertical, the horizontal only exists on the outsides. Okay? The inside could look like a parabola, or it could look like a cube. And the only way to know is to plug in the numbers. The outside parts are going to look like what we've already done. So if I do my T-chart for the outside, I would plug in -3, -4, and on the other side I'd plug in 6 and I'd plug in 1. Well, when I plug in -3, I get -3/4. When I plug in -4, I get -4/9. When I plug in 6, I get 1.5. And when I plug in 1, I get, 7. I get 7/9. So these, -3, -3/4, -4, -4/9. So this one, it's like that. -6, 1.5. 7, 7/9. Looks like this. Okay, now to find the middle, we're just going to have to plug in the points and see what happens to them. We're going to see, like, do they start up, come down, and go back up, or do they kind of do like a line, so we make them look like a cube. The only way to know how to do that is just by plugging in the numbers. So I'm going to plug in all the numbers that are in the middle. So negative 1, 0, 1, 2, 3, and 4. Okay, when I put in negative 1, I get a third. When I put in 0, I get 0. 1, I get negative a sixth. 2, I get negative 1/3. 3, I get negative 3/5. 4, I get negative 1 1/3. Okay, so what's happening is if I plot these points, they're all going down. Well, if they're all going one direction, up or down, it's going to be a cube. So this one, then I go connect all my dots, and then I draw it down to the line. Okay, this is the video that you will need to do in order to do the homework. That is page 558. You're going to do 13 through 18 all. Okay, and I want you to do that on graph paper. So the sub should give you graph paper. If not, you can check my desk or check the podium.